I had to go back and remind myself what I'd shared on this project because it has been a while. I showed the new turntable based on the 28BYK stepper. I showed capturing first light with the OV5640 camera, and I also showed using OpenCV to do the calibration for that camera. But it doesn't seem like I shared anything since then, which is a bit strange. I've done a load of work on this project, and intended to make some videos about that progress, but then I didn't. Instead, I've been waiting for parts, which have now just arrived. So in this video, I will bring us up to date on the progress I've made so far, and I'll mention the new parts, and then after this video, I'll dive into trying to capturing some scans with the new parts and figuring out what the new challenges are. Okay, I'm going to talk about camera settings for quite a while. Because of the field of view of my camera, it's a wide angle lens essentially. I'm not interested about most of the peripheral in that view. It's only really the center I'm interested in. And the pico that I'm using has a maximum amount of available data it can store of about 150k. Ideally, I'd like about 1.5 meg, and then I could capture a 900 by 900 pixel region of the screen at full resolution. But again, I don't really care about most of those pixels. I really care about the red ones where the laser is contacting the surface of the object being scanned. Most of the experiments I've been doing so far have been with the default camera resolution of 2560 by 1440 using a high compression of 24, which allows me to store the output images in the 150k of RAM on the pico. The Python library I'm using for capturing images is really good. It's really good, as always with Adafruit stuff. It sets hundreds of registers behind the scenes for capturing and outputting the data. But the output size is set using an enum, which is an index into a table of values. So that enum gives you default pre-configured resolutions and the settings necessary to capture them. I didn't want to entirely abandon that library because it's setting dozens of useful register values for me, but I did want to use an output format that's not one of the pre-canned enums. I wanted to use a custom crop and a custom resolution. Whilst the library itself is compiled into binary, I found I could actually overwrite values in the table the enum indexes into, which gave me a bit of a workaround. I could write in my own values into a row in the table and then choose to use that row. I started off by copying all the values from a working row, and that allowed me to confirm that my hack was working. And then I could gradually change those values, setting offsets to shuffle a cropped window along to where I wanted it. With a bit of trial and error for these values, I managed to shift the capture window to be 950 pixels by 950 pixels without scaling. And that's pretty much perfect for the actual field of view that I want. Because that's capturing fewer pixels, I can then lower the compression factor from 24 down to 6. It's very close to 5, but not quite. The next issue to address was the noise. So the library is very video focused and doesn't expose the settings related to auto exposure or auto gain controls. So here again, I had to go to the datasheet and start messing about with individual bits in registers. My approach for tweaking these camera settings in the registry values was to boot up the Pico, have it set a set of known settings and take one picture, and then alter the settings and take a second picture. And that allowed me to do differential to see if it was changing and if the known good state was working before changing it to the slightly dodgy state. Having iterated a few times on that, I tried a setting to control something and found it made an amazing difference to the noise level. So I committed immediately, and then I tried the same code again and it was rubbish again, noisy. It took me a bit of head scratching that one, but what happened was Between the two attempts, the sun had moved slightly, and I'd gotten up and closed one of the curtains in here. As a result, I'd reduced the amount of background light, which changed the automatic exposure or automatic gain control settings. So at that point, I started investigating whether I could turn off the automatic gain and exposure controls. I managed to do that, and that seems to also have resolved a large amount of the image corruption. Now I can capture reasonably low noise images with minimal compression and crop it to a region of interest. So the object of interest sits on the turntable in front of the camera. The camera takes a picture and writes it to the SD card, which is quite slow. The turntable then turns 3.6 degrees and a new photo is taken. Once I've gathered those pictures from the SD card, I can stitch them together to make these essentially time-lapse videos. Because I'm showing all these time-lapse, you might think it's quite an efficient scanner, but this is it in real time. It takes a photo and then spends about 10 seconds writing that data out to the SD card before advancing the turntable 3.5 degrees and then repeating the process. It takes about 20 minutes to do a full scan, but it is a fully automatic process, so you can go get a cup of tea and leave it to it. So this may not be very much to look at, but it's actually quite a big deal in terms of progress. What I have is a little R2-D2 figure sitting on the turntable, and it's being illuminated by the laser, and I'm taking these cropped, higher resolution, low compression images and stitching them into a full revolve. I can use OpenCV to remove distortion from these images and then extract the line and project that into this space to form a point cloud. Now there's no X, Y or Z calibration of any sort on this, but it does vaguely look like R2-D2 in there. Noise is very much the enemy here, and I am struggling to figure out the right exposure settings. In the left image I'm actually shooting inside a box, so it's very dark, but then I've turned down the exposure. On the right I'm shooting in ambient light, but with slightly higher settings. One problem I uncovered shooting these side-by-side videos was that my turntable is actually not consistently turning 360 degrees. Here is the scan data for that hat scan taken in ambient light, and you can see all of this extra noise here. There is a vague shape in the middle, but it's extremely hard to differentiate from the background noise. So what's next? I need to calibrate the data in X, Y and Z. I've got a few ideas for that, but I've not done it yet. And I'm going to need more data. I want to be able to average out some of that reflectance and noise. And also the incident angle of the laser isn't good for some shapes. The simplest way I could think to do this is to add a second laser of another colour, although it turns out it's much harder to get lasers other than red. I would like to do a colour scan too, but if we think about how that would work, well, the pixels where we know the shape are going to be obscured by the colour of the laser. But once we know a surface point in 3 dimensions, we should be able to look in another image and work out where that point got rotated to, and then we can sample the colour at that pixel that's not under the laser line. The biggest obstacle to that I can see is going to be the reliability of my turntable. I noticed making the looping videos that it doesn't always rotate 360 degrees exactly. In fact, it doesn't even step reliably now I've investigated it. I hadn't heard good things about the little 28B YK steppers, but just using that little stepper was so much more convenient than trying to build a gearbox. I spent a while sketching out designs for indexed gears and even a Geneva drive, but it was hard to miniaturise the way that I wanted. So my approach for now is just to buy a better motor with a gearbox. And I've bought these tiny DF Robot FIT0503 micro metal geared stepper. It's even smaller, but it's not got to do a lot of work. I've 3D printed these adapters so that I can fit it into the shim and then fit the shim inside the old housing. So it's not actually a big change. From the experiments I've been able to do so far, I've only had it a day, it does appear to be more reliable in terms of stepping and have less backlash than the previous one. So hopefully I can get both lasers to correspond between frames and maybe even get the colour sampling to work between frames if I can rotate a reliable angle between the frames. Anyway, that's plenty for now, so I'll update you on progress in a bit. Thank you for watching and stay safe.